Welcome you all for today's session, dual slope type ADC. Why it is named as dual slope ADC? Because here the ramp signal generates two different type of slopes. One is with the known reference voltage and another one is with known analog input voltage. That is why it is said to be as dual slope ADC. So let us discuss about the working principle of dual slope ADC. Already it is very clear that dual slope ADC comes under our integrated type ADC. As I said, there are two types of ADC. One is direct type and another one is integrated type. So flash type and successive approximation type comes under our direct type ADC, and dual slope and single slope type comes under our integrated type, that is indirect type ADC. Why we used to name it as indirect type ADC? Because we are not converting the analog data directly to digital data. First we are converting the analog signal into some certain linearity of time or frequency, and then we are converting into digital data. So this is why it is called as integrated type ADC. Because of this integrated type, the difference between direct and integrated is the time delay is reduced here. So this is the main advantage of our dual slope ADC. Let us discuss about the block diagram of dual slope ADC. So this is the block diagram of dual slope ADC, which consists of three inputs. One is our known reference voltage and another one is our known analog input voltage and one ground switch. So why we are naming this dual slope? As I said, we are generating signal by using two input voltage. One is known reference voltage and another one is known analog input voltage, and we also have an additional input voltage, that is our ground. So here first we have one unit named as switch. Next we have three op amps. One is high integrated type op amp and another one acts as an integrated circuit, a high impedance circuit. First one is high impedance buffer and second one is integrated type and third one is comparator. So all the three op amps acts like buffer, comparator and integrator. We know very well about the function of buffer, comparator and integrator. So first the switch is giving we are giving two input voltages and we are just starting the conversion. So this first voltage, known input voltage, and the reference input voltage is always vice versa. If known voltage is 0, our reference voltage will be 1. So these input voltages will be given. So first high impedance buffer will convert the signal, will convert high into low and low into high, and then it is passed to the integrator circuit, where the integrator defines the difference between the two input voltages. So the integrator circuit, we know it forms by resistance and capacitance circuit, we can see here, and if there is any offset voltage while converting, that error can be rectified by using an additional capacitor, which is given here as CAZ. Then at last the third op amp compares the data and the output is given to control logic. This control logic consists of two functions. One is start to convert and another one is end of conversion. So this is used to start and end the conversions, and at last the data is transferred to end stage counter, where the counter delivers the digital form output D1, D2, D3. And this is the graph of dual slope integrated circuit. Coming to the features of single slope and dual slope is common. Both single slope and dual slope features are common, like comparison with reference voltage, ramp generation and time proportionality, and digital counter by using digital counter. The advantages of single slope and dual slope converters are like high accuracy, wide input range and low noise sensitivity. These are all the advantages of dual slope. And coming back to disadvantage, like clock drift, component sensitivity, temperature effects, calibration drift and speed limitations. At last we can end with applications of dual slope converter, like it is used to accurate measurement of physical quantities such as temperature, pressure and light intensity, and also it is employed in medical monitoring equipment to convert psychological signals into digital data, and it is also found in devices that require analog to digital conversion such as digital cameras and audio equipments. Thank you.